This is Unit 2, Lesson 7, Angle Proofs Given Parallel Lines. So that's the key piece, that we are being given the parallel lines. So we're going to prove angle relationships if given two parallel lines cut by a transversal. Our relevant prior vocabulary: parallel lines, alternate interior angles, corresponding angles, alternate exterior angles, vertical angles, linear pair, supplementary angles, and any properties, postulates, or theorems that we've covered, especially that lesson 6 vocabulary that you completed already. So a theorem is a mathematical statement that can be proven. It is typically written in the form if, then, or hypothesis, conclusion. Once a theorem has been proven, it can be added to our list of known facts and used in the proof of other theorems. So there are 3 parallel line theorems shown below in the original section. So if 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. If 2 parallel lines are cut by a transversal, then the corresponding angles are congruent, and so on and so forth. And again, these interior angles on the same side remain consecutive interior angles. So there are 3 parallel line theorems used when given the lines are parallel, and each of these theorems has what we call the converse in mathematics, which is really just the reverse, used when we are proving that lines are parallel. So in this lesson, we will be using the first 3, or the originals. This is what we will be focusing on. Right? In the next lesson, we will be proving that lines are parallel, knowing that these angle relationships exist if indeed the lines are parallel. So let's recap real quick these angle relationships. When 2 lines are parallel and cut by a transversal, we know that the alternate interior angles formed are congruent or equal in measure. The alternate exterior angles formed are congruent or equal in measure. The corresponding angles are congruent or equal in measure. And the consecutive interior angles, or same side interior angles, are symmetric, which means they split 180. Again, supplementary is a term that can only be used for 2 angles. Okay, so we're going to write a proof to prove alternate exterior angles theorem, which says if 2 parallel lines are intersected by a transversal, then the alternate interior angles formed are congruent or equal in measure. So remember, you cannot use this theorem or relationship if that is what we are trying to prove, but we can use other relationships or theorems that we know. Right? So given that line FJ is parallel to K, and again, we give you information, annotate it or mark the diagram with that information. We want to prove that angle 1 is congruent to angle 2. So because they want me to prove that something is congruent to something else, I will try to use congruency symbol in my statements and when I explain my reasons. So with every proof that we do, we always start with given information. That's the default proof. If we are not given this information, it would be very challenging to make it. And when the reason is right there. So number 2. I see here that I have vertical angles. So angle 2 and angle 3 are vertical angles. How do I know they're vertical? That's the definition. Where is the table blank is the definition. Vertical angle, definition of vertical angles. Well, now that I know that it's vertical, I know that angle 2 is congruent to angle 3. Vertical angles are congruent to one another. And notice I said congruent to one another, not equal in measure, because I used congruent in my statement. And again, what they want me to prove uses the congruency symbol to one another or each other. Right? Remember, that is a group of statements we did definition of corresponding angles. Then let's open it right up. Because the line is parallel, we know that angle 1 is congruent with angle 3. And this is the important piece. When two parallel lines are cut by a transversal, the corresponding angles formed are congruent. Alright, again, that is a group of statements that go together. So our last statement is always what you're trying to prove. I now have enough information to prove that angle 1 is congruent to angle 2, and I know that by the transitive property. And you can just transitive if you don't